Okay, we're going to have a quick look at the angle between two vectors. And we'll start with on 2 dimensions. Because the internet, I'm uploading this because we seem to be having internet problems in school. So if we have 2 vectors and we find the argument for them, we can find the angle between them. Okay, so we can actually find these 2 angles, and therefore we can find the angle between this angle. If I say this vector is 3i plus 4j, and this vector over here is 6i plus j, we can find the angle between them by finding the 2 vector points. So let's do vector A, vector B. Now, in a minute we'll come back and we're going to apply this to a different technique as well for finding it. But let's start off with just the argument. So the arc of A is the arctan of 4 over 3, which should be about 54 degrees, it's 3.1 degrees. The argument for B is the arctan of 1 over 6, 9.5 degrees. So the angle between them, we are finding, is theta. It's the difference between those 2 angles. That's one way to go about it. There is another, and the other one I'm going to stick to 2 dimensions for the moment. But if we were to look at this as a slightly different problem, when we're dealing with triangles, and we know this side as well, or we want to know this side, we've got a way of calculating this angle C. If we know the side C, and there's A, and there's B. Okay, so if we can find what the length of A is and the length of B is, we can find, using trigonometry, C squared equals A squared plus B squared minus 2bc cos 2ba, cos of the angle between the 2 lines. So this is actually, in terms of our algebra, we can actually find the vector C, which is B minus A, because of the way that I'm showing it. So B minus A. So if we take those away, we get 6i plus j. Subtract from that 3i plus 4j. And my resulting vector is 3i minus 3j. So we can now actually find out the lengths. So the length of A is going to be length of A is the square root of 3 squared plus 4 squared. And that we know is going to be 5. Square length of B is the square root of 6 squared plus 1 squared. This is the square root of 37. And C is the square root of 3 squared plus minus 3 squared, which is the square root of 18, which is 3 root 2. And we can actually then work out this angle C between them using those values. So cos of C is equal to my C squared, which was 18, 3 root 2 squared, minus a squared minus b squared, all divided by minus 2b times a. Which is going to calculate out as, so top bit works out minus 44, bottom bit minus 60.8, and if you do the division of those, you get 0.72, and so we can calculate C is the inverse cos that one's, which is 43.6 degrees and 7 degrees. And I forgot to do the calculation before, which is 43. And this is because this is rounded, 43.6 degrees. So these are actually the same values. So this second method actually is related closer to our roots, our vectors. And the trick in this is being able to find this vector. By being able to find that vector, we can find its length, and the vector sum allows us to find it. The result comes down to a position where we now need to know how to calculate this vector C and how we can actually link that to the other one. So I'm going to do some algebra as a separate video, but the result of this trick is if I do the modulus of C all squared, which is b minus a, what we can get down to is the result, can get to the result of the scalar product of two vectors a and b, and this scalar product is multiply all the x bits, the y bits and the j bits together, is equal to the size of vector A times the size of vector B times the angle between them. This is my angle C that I found here. This is the result. Algebraically, I'll prove it in another video to follow. So what you can do is, for some practice for the moment, is create some vectors of your own, play with them. So if I have two vectors like this, so this vector A is the column vector of -3, 2, and this one B is a vector of let's say 4, 2. The A dot B is multiply the two I parts together and the two J parts. So we get -3 AI part times BI part times 4, and we add to it the J parts. This gives me the size -12 plus 4 is -8. And this is the vector product of these two. If I calculate the size of A, is the square root of 9 plus 4, so the square root of 13, and the size of vector B, the square root of 4 16 plus square root of 20. We can actually rearrange this equation to find the angle between them. Cos of theta is minus 8 divided by the square root of 13 times the square root of 20. And so the angle is shift cos, that answer is 119 degrees. 119.7 degrees. And you can verify that by finding the vector between them. And the vector between them is going to be, it's going that way, so it's going to be 7, 0. And you can actually verify this angle by using cosine. Well, and you can verify that calculation. So I'll give you some angle vectors, find the angle between them. Check them in both ways. So do the dot product method. So the dot product divided by the product of the magnitudes. And check that you get the same angle both ways. This is simpler when it comes into 3 dimensions, and I'm just introducing it for these 2-dimensional ones.